The Cloudcast is sponsored by Intel Cloud for All, driving the creation of tens of thousands of clouds.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are. Welcome back to the Cloudcast. We are live from Raleigh, North Carolina in the massive Cloudcast studios. Just me tonight. We always like to mix things up a little bit. People give us tons of good feedback on, they love the stuff around DevOps, they love the stuff around cloud native, and they love the stuff around startups. And, sometimes we dive into different parts of things that maybe we don't cover a whole lot, but, there's interesting aspects of it. And tonight we're going to have some fun. Kind of an old friend of the show, but first time on the show. Chris Marino joins us. Chris, how are you doing today?
I'm doing great, Brian. Thanks for the invitation.
And for anybody who doesn't know, Chris is we got to know Aaron and I got to know Chris back when he was CEO of a company called vCider, probably 2 or 3 years ago, which sold to Cisco. But you're now founder and CEO of a brand new company, Pani Networks. So congratulations on that. So
thank you.
So before we jump into kind of what you guys are working on, give us a little bit of your background. I mentioned vCider, but you've done a bunch of interesting things. Give folks who don't know you a little bit of your background, and then kind of lead us into what's going on with Pani and why'd you guys get started.
Great, thanks, Brian. So let me start with a little bit of my background. So I'm an engineer by training, bachelor's and master's degree in electrical engineering and in computer science. My first job was actually designing microprocessors. So my degree was in semiconductor physics and all that transistor level stuff. Then I actually moved out of that and did product management for a while at an old systems manufacturer in the old Silicon Graphics, MIPS, Sun Microsystems days. But my first exposure to networking and deep exposure to networking was actually in the mid 90s with interactive television and video on demand trials, and I got very, very involved with that. In fact, I've been an entrepreneur basically my whole career, and actually left to start a video server company. But then just coincidentally, Netscape went public that year, and quite literally overnight we pivoted to become a server load balancing company. Okay. And that company was Resonate, and that company was pretty successful. We were competing with F5 in those days, and the company went public, and we did some really interesting things in those early days of the web. So anyway, I did a couple of things over the intervening years, but then again, things sort of picked up again in sort of the early cloud computing revolution days of 08 and 09, and that's when I started vCider. And I think I'd like to say a little bit more about vCider because I think it relates to some of the things we've done with Pani Networks today. The very thesis of vCider was cloud is experiencing explosive growth. Yep. People want to bring their enterprise applications into Amazon EC2. And the only way they're going to be able to do that if it has an enterprise network available to it. And what that literally meant was a VLAN. So that was really what vCider tried to do, was bring a VLAN into Amazon. And that's what it did. And what we learned, unfortunately, was that people were quite happy running in Amazon without a VLAN. And that realization came to us quite quickly. And the wonderful news here is that Cisco saw what we were doing and liked it. And they acquired us. You and I both worked for Lou Tucker, by the way. Right. And we didn't overlap. So you left a little bit before we jumped in. But I think we missed each other by about 7 or 8 months. Yep. But anyway, funny story here, Brian. So when I was trying to hire product managers and SEs, he was always say to me, Chris, you really got to hire guys just like Brian Gracely. He was one of our best guys.
Yeah, Lou is great.
True story. Yeah, honest to God, true story.
Lou was fantastic. He was fun to work with, and super positive guy. Always had sort of a big vision for where to go and stuff. So yeah, you're right. I mean, it's when you reached out to me and you said, "Hey, I'm doing something new," and I started digging into it, and we're going to talk about that tonight. My first thought was, networking is changing because of containers and because of these new things. But I went, boy, Chris has a whole bunch of experience from having done this before and dealing with not just networking, but dealing with, these cloud management systems and kind of the interaction between the two of them and how things are changing. So it's a feels like it's, like you said, it's a natural progression of what you learned in the past kind of feeds and builds on what you guys are building now.
Yeah, exactly. So, another thing that, you and I talked about in advance is that, the whole term SDN has sort of morphed into become everything and everything. And it's sort of almost to its own detriment. And, one of the things that I've struggled with myself is like, how do you parse SDN? What the heck does that actually mean? Because everybody uses it sort of, it's almost like a throwaway term. And what's helped me is, to recognize that networking is such a big industry, and there are a lot of special areas of specialization. And just like, network specialization, there's areas of software-defined network specialization. Yep. And, for me, what I have found, it's quite helpful to sort of just give, put things in different buckets. And what's been helpful to me is sort of, break up the whole SDN category into a couple of more meaningful buckets, and I'll just rattle them off here for you. I have one that I call the enterprise SDN, and the enterprise SDN is what people generally understood VMware NSX to be. A virtual network overlay with tunnels and encapsulation and all that stuff. And really the objective of enterprise SDN was to do what vCider did, which was, hey, I want a VLAN, and I want this VLAN anywhere I want to go, and be able to build, vMotion, build apps that can take advantage of vMotion in my environment. And that's what SDN can do. That's what NSX can do, and I call that enterprise SDN. Yep. But that's really different than a whole other very important area of SDN, which I think people are starting to call, software-defined WAN or a WAN SDN, and that's a very focused solution to optimize the way people use their telco and internet service provider links to optimize that network. And so I think of SD-WAN as an SDN approach, but very different from enterprise SDN.
Right.
So I think that's helpful. And then also another thing that gets really complicated and intertwined with SDN is the things that AT&T and Comcast and Verizon and Deutsche Telekom are trying to do to automate and virtualize their own back-end infrastructure. I call that carrier SDN, and there's a whole bunch of initiatives around building dedicated controllers to virtualize network functions to reduce the capital cost of building out a carrier backbone. Right. I call that carrier SDN, but that's very different. It's very important from a telco provider, but very, very different from NSX, and very, very different from the SD-WAN products. So that I think that's very helpful. But also, Brian, what I take away from this as well is that, as we look forward to the way new applications are being developed, specifically targeted for deployment on cloud infrastructure, I used to call this Amazon-style apps, and everybody knew what that meant. And fortunately, there's a new name for that, and people now call that architectural style cloud native.
Right.
So what I see is that has sort of taken over the application architecture of choice for new application development, and importantly, it doesn't displace legacy applications. They're still going to be around. They're going to need enterprise SDN, but looking forward, I believe a whole new category of cloud native applications is going to be built. And what I recognized while at Cisco and in some other experiences with vCider is that, cloud native applications have their own very distinctive network requirements that are different than WAN SDN, than carrier SDN, than enterprise SDN. And in fact, there are actually some kind of big, ugly problems with running cloud native applications and things like OpenStack. And kind of that's the problem that we set out to solve with my new company, Pani Networks.
Yeah, and I think I think the categorization you have is really good. I think it's important for folks to kind of think about the basic things there. The enterprise SDN piece is really how do I create essentially a layer 2 adjacency, like you said, create a VLAN, make things look like they're next to each other for applications that don't really want to think about complicated networking in between them. They're just kind of built that way. Plus, there's now this big sort of micro segmentation thing, which is mostly focused around, can I put a firewall or some sort of security boundary like right near the virtual machine, right? That's kind of what enterprise is. Like you said, the NFV function, the carrier SDN function tends to be about how do I virtualize a load balancer, a caching appliance, anything that used to be a physical hardware box, which was expensive for a carrier to put anywhere. They now want to virtualize it. And I think that the interesting thing is, people tend to go, okay, networking's networking. And then like you said, when you start putting it into places like Amazon or you put it into Azure, a lot of those basics that we used to take for granted, like I can find a neighbor, I can send out a broadcast on a wire and find a neighbor, or a multicast on a wire and find a neighbor, or, I'm going to have some sense of what my adjacencies look like, or, I'll be on the same subnet. Like a lot of those you can't take for granted anymore because of the way that
exactly.
Amazon does networking, because of the way they do security groups. And so it does sort of mandate a new kind of, intelligence around the networking stuff. And I think that's right where
exactly.
you guys are trying to be the sweet spot for.
Exactly. So here, let me tell you a funny story from the vCider experience. So I'm a networking guy. I know the difference between a layer 2 and a layer 3 network. I know what broadcast domains are. So I'm thinking, well, of course they're going to need layer 2 broadcast domains. Naturally, of course they're going to need it. So we had this overlay technology that could be deployed inside of Amazon, and it basically built a VLAN, which was a flat layer 2 broadcast domain. So I'd talk to Amazon developers and I'd say, I got this great thing for you. It brings a VLAN into Amazon. It gives you a flat layer 2 broadcast domain. You can ARP, you can run your CIFs, you can run your Microsoft applications there. And they'd look at me and they'd scratch their head and they go, layer 2, huh? Says, I think I got that. Here, let me show you. Here, and he'd ping. He goes, look, ping, 52, blah, blah, blah. And says, I can ping that. I think I got that. Thank you. And I go, holy cow. This was like the eye-opening experience of a lifetime. The curtain went up and I said, holy cow, I am interacting with an entirely different developer that really has no interest in the details of what traditionally, network operators, live their lives around.
Right. Which is, we had things like Oracle Oracle's rack would need a broadcast domain. It would need to be on the same subnet. You'd need all these basically high availability services. Even things like Cisco HSRP, they all required you to be on the same subnet. And now all of a sudden, because Amazon by default didn't put your stuff, necessarily reachable, people just went, all right, I got to work around that. And now you've got a wholly different mindset. So
exactly. And that was, and what you said, you have to work around that. And that was really something that I did not expect, is that Amazon has been fantastically successful in training an entire new generation of application developers to work around those things.
Yep.
And, and it's, to my mind, that's an insanely high competitive advantage because they have that developer mindshare.
Yeah, and it's another thing that, a lot of people, I remember back in, 08, 09, 10, people were saying, well, and this is when you had a lot of the big vendors, and they still do this, but, we're sort of saying like, well, you don't want to put things in the cloud because your application wasn't designed for the cloud, and it doesn't need scale, and it doesn't need all these things. And what you sort of eventually realized was stuff like, well, it didn't matter if your application needed to scale. Like if your application was built expecting the network to do a certain thing, and that network didn't do it, it didn't matter if you needed 2 servers or 10 servers, you were going to have the same problem. So yeah, I think I'm not sure people still completely understand all the nuances and differences there, but it's important that the people that are helping, these new cloud native environments, that they're making it as seamless as possible. So let's, jumping off from there, let's talk a little bit about what you guys are doing with Pani and this thing you're calling the Romana Project.
Great. Yes. So the company we started is called Pani Networks, and we're going to have a commercial offering that goes around that we have not announced yet. So Pani Networks is the sponsor of a new open source SDN solution that's focused on the requirements of cloud native applications. We call it Cloud Native SDN. And the Romana Project is, again, open source software that addresses those requirements specifically. And what we do is we take, I think, a very different approach to solving the problems of networking for cloud-native applications. And we're able to simplify the solution a great deal because we're not solving the problem of the enterprise LAN. And We're not trying to solve the vMotion, provide support for vMotion and some of these other enterprise-y kind of applications. So let me tell you a little bit about how it works and how that's different, and sort of the insight that we had that allows us to do what I'm describing here. So let me start by saying maybe a really, really simplified, maybe even oversimplified explanation of what Romana does from a software perspective is really, it kind of takes the whole cloud networking problem and turns it inside out by turning a really complicated network reachability problem into a much, much simpler IP address management problem. Now, let me go into a little bit more detail to explain that. So when you think about virtual networking, it's really an effort to build isolated network topologies on top of a fixed physical network underlay.
Right.
And virtual networks start by building isolated networks on each host, and then they build an overlay network between all of these hosts so these isolated networks can talk to each other.
Right.
Well, that is a huge reachability problem. You've got tunnels, encapsulation, routers, VTEPs, BGP, route distribution, EVPN. Holy smokes. Your mind just spins with the complexity that goes along with that. And that's what VXLAN does.
Right.
Now then you add on top of that the enterprise requirements. They want to add to that, layer 4 to 7 services, firewalls, load balancing, security, and so forth. That's a really big problem. And that's exactly what NSX does.
Yes.
And that's exactly what I described as what enterprise SDN is. Okay, so coming full circle back to that. So what we recognized was that cloud native applications don't have those complex network topology requirements at all. The only thing they need is an IP address that's reachable. And if you can go to the Kubernetes spec, and it has almost zero network requirements. You just need a routable IP address. So what that means is that you can take the existing physical network as it already has been built and use it directly, because it was built to provide endpoint reachability. Whether it was built using a simple layer 2 switch network or a fancy fabric, or what's common today with large data centers like Google and Facebook, or spine leaf routed layer 3 designs, it really doesn't matter. But you can run cloud native applications on top of that. But importantly, what the physical network does not provide is the isolation mechanism that comes with VXLAN overlays. So really, that's what Romana brings to the existing physical network directly, a way to build multi-tenancy into the existing physical network.
Okay.
And the way we do that is by carving up the entire IP address space so that each tenant has its own actual physical network. And isolating networks is something that routers have been doing for decades. Okay? So what we've built with Romana, it's a route controller that configures the Linux kernel on each host to perform standard routing between tenant networks, and then add firewall rules with IP tables to provide the isolation. So now one important remaining problem is to ensure that when an IP address or container is added on the host, it gets the IP address that's within the tenant's network, and also maintains the physical network addressing scheme. So this IP address assignment also needs to be coordinated with Kubernetes or the orchestration system. And Romana has this exact system. It's our IP address management system. Okay. So in this way, we can take advantage of route aggregation to avoid running BGP or run a distributed key value store like Consul or etcd for route distribution. In fact, the whole route distribution disappears entirely. So what the end of the day, what this means is there's no encapsulation, no tunnels, no OVS, no Open vSwitch database, no BGP, none of that stuff. It all just disappears. And then, the final, icing on the cake here, Brian, is that, since every endpoint is using a physical address that's running on a physical network, all existing physical network devices, security, and management tools that are already in place just work. So, that's really a godsend for the network operator who's there that can do what he's been doing all the time and still get the multi-tenancy that they're looking for when they deploy these applications. So that's kind of what it does. And just to be perfectly clear, this is not an enterprise SDN. It's not going to support VLANs and overlays. But for the new cloud native style apps, it's a solution that allows people to deploy them on their physical infrastructure or even in Amazon without the overlays.
Okay.
That make sense?
Yeah, no, it starts to make sense, and you know, I'll sort of say this for the audience and the listeners. This is probably one of those talks that would be better if we had a big whiteboard. The good news is, if you guys are running or in your car or something, there's pointers in the show notes for this to all the documentation. Chris's team does a really nice job of mapping on this all out. So lots of visuals for people that are big into networking. You get to see kind of how all this breakdown works in terms of tenancy, where the isolation is, how the addressing stuff is meant. So my advice to people listening is just kind of soak it in. Don't feel like you have to kind of mentally draw it out in your head, because Chris's team has kind of already done that. You can go back and take a look at this stuff and dive into it much, much deeper. So that stuff is sort of fascinating, because the trick with these cloud native applications is, you have a couple of principles that are very different, right? One of them is, the services are very decoupled. So you don't have these sort of natural patterns that you had with client server, where it's like, all right, load balancers, maybe a firewall in between there, and then another, where stuff kind of intersects with each other is a little bit, can be kind of random sometimes, depending on when a service is added. And the other thing is, these services, may end up sort of having a very long life, and in other cases may have a very short life. And so you need a mechanism that's fairly dynamic to figure out, okay, what exists, and then, like you said, get at its most basic things, like an IP address. Can you walk us through just maybe like a common, let's say somebody builds a microservices-based application. Maybe it's got 8 or 9 services and it runs across a couple hosts. Can you give us a sense of kind of, break us down the basics of what's going on those machines? How do they figure out where a service is, and some of those basic things? Sure.
So, very fundamental to the whole cloud native architectural style is the idea that a service is built up from replicated service endpoints. The whole pet versus cattle metaphor applies directly here. There is no regard for this virtual machine as compared to that virtual machine. These things can pop up at random, willy-nilly. Kubernetes, actually, that's their whole, their intelligence actually is in its ability to basically schedule the creation of these service endpoints wherever they need to be, whenever they need to occur. So they're dynamically being created and shut down, and they can show up on any host anywhere. Right. So that's sort of really intrinsic to the whole architectural style of cloud native applications. So, and again, it comes back to what the networking requirements are. So the way this would work with the Romana project would be as I said, a tenant would get an entire network to themselves, and then they could choose to carve up that network however they wanted to. And what is logical, getting back to your question about microservices and the whole cloud native architectural style, very often people build up services out of replicated endpoints, and that collection of endpoints is a grouping of endpoints that is known as a service. Uh-huh. Well, what we can do with our networking approach is to define the boundaries of that service to also be the natural boundary of the network. And sort of that one-to-one mapping between a microservice and an actual real network actually simplifies a whole bunch of operational logistics. So, for example, being able to apply security rules to all those different individual endpoints really means I just need to apply a security rule to the route, to the gateway, to those endpoints. So again, the complexity of managing the security and the access collapses by taking advantage of the natural segmentation that comes with these networks that Romana can manage. So the way this actually would work is you could define a service, and that service would have a physical network associated with it, an address range, and it would have a tenant identifier as well as a segment identifier. And then whenever Kubernetes launched an endpoint or a pod on that service, our IP address management would be sure to assign it an IP address that's within the appropriate range. And to be honest, that's all it needs to do, because at that point, the network has already been configured to accommodate that network. This is just another network, another endpoint on that same network that exists. So the work that needs to be done is very quite straightforward. All it has to do is issue an IP address to that endpoint, and then its job is done. There's no BGP, there's no convergence, there's no route distribution, and that again really simplifies the way these applications can be deployed. And then getting back to your earlier question about the speed with which these things might change, since you don't have to inject a new route into the network and you don't have to let BGP distribute and let routes to converge, you can do this much, much faster. Again, it's all statically configured, and all you have to do is load the endpoint, bring up the interface, and you're done. And that allows and supports that velocity of change that people expect when they're building out these new cloud native apps. This is a little forward looking. I don't think a lot of people are there yet. But as we look forward and you hear what people want to do, this is exactly the future that they envision.
Yeah, and I think there's a couple of really important points in there that we should make sure we kind of pull out. So, when we're talking, we've talked a lot on the show about containers and Docker, and the reason people like it, is part of it is it's very portable, right? Developers can write what they want, but the other thing is containers are fast. I mean, they boot super fast. They come up really quickly. They can get torn. I mean, they're essentially like processes. You have to sort of connect the dots and go, if I'm going to have this environment that is super fast to come up and run, I can't have these networks waiting to converge, right? I can't wait for, DHCP plus a route to update plus a flapping route. So that's really important, right? So you're exactly right. Well,
Brian,
a fast network, that's really important.
Brian, you really touched on a very important but extremely subtle point when it comes to the networking side of containers and networks, because sort of the devil's in the details.
Yep.
And you go to DockerCon and they talk about the lifespan of a container being, I don't know what it was. Was it like 8 seconds or some crazy thing like that?
It's less than minutes in a lot of cases.
And then you realize, well, wait a minute. That means some of these things might live for literally 5 seconds, less than 3 seconds. And how do you get the network to respond and provide access in that time? Well, first, I can tell you can't. Right. The network just doesn't allow for it. Right. So there's sort of that elephant in the room that nobody's really gotten to that point to even appreciate that problem. And again, this is a little forward thinking. Again, I don't think people are bumping up against this. But again, as I hear the conversation around what people want to do with containers, just the way you describe it, I look and say, that's not going to work. Right. That's just not going to work.
Well, and the other thing that I think is important, and again, this is sort of a subtlety, but connecting the dots is, we've talked on past shows about things like immutable infrastructure and this idea of sort of, you're defining it as if it's code, defining what your environment's going to look like, because if it falls down or you want to expand it, you want it to look exactly the way you want it to look. And the systems aren't sort of standalone anymore, right? Like you said, something like Kubernetes or any of these scheduling tools like a Docker Swarm or something, it essentially is saying, this is what I want the environment to look like. I'm going to kind of keep track of it. If something dies, I'm going to rebuild something else. It's got to have a system that has that same sort of describability, immutability, codability. It's sort of just codified. And you've got to talk between these systems. And that's really different than we had in the past. I mean, in the past you had, an application that sort of knew about its other application components, but you had to worry about stuff like, well, if it falls over, which order will it come back in? Will the database come up before the things authenticate to the database? These new systems, in the way that they're interconnected, they come back, at least in theory, they come back exactly the way you wanted them to come back.
Right.
And you've got to have system components, not only at the application layer and the container layer, but at the network layer that can kind of work in that mindset.
Exactly. Fun stuff. Fun stuff.
Very interesting stuff. Yeah, and I know, back in the day, I remember people like Arista were doing this, where they would tap into vCenter and find out what VMs were being built, and they would sort of build MAC addresses in the network. So a lot of this stuff isn't totally new, but the more and more you're building environments that are rapidly changing, are rapidly scaling, you have to sort of build that to be an automated function. You can't rely on. So it's cool that you guys are taking the learnings from the past. You're moving it forward into a space that, like you said, probably is much more relevant than maybe what VLANs were a few years ago and so forth. So that's very, very cool. Well, listen, like I said before, some of this stuff you kind of have to visualize it. It's good to see that the awesome thing about all this stuff nowadays is, that there's open code to go play with this. When you guys release this, there'll be code. It'll be an open source. It's all written in Go, so it'll kind of natively plug into stuff. Give us a sense, because we're recording this a little bit before you guys are kind of launching. As soon as this goes out there, like give folks a sense of how do they get in touch with you? Where do they find the code? All that sort of good stuff. Great.
Yeah, I'd love to, Brian. So yes, the code will be available. We're opening up the repos on Monday, February 1st. So if you're listening to this now, I'm sure it's available for you to check it out. And that's available on GitHub at github/Romana. The project site is romana.io, and there's a ton of information there. Brian's already mentioned that. There's diagrams and backgrounders and all sorts of interesting information there. You can reach any of us at info@romana.io. So lob a question over there if you have any questions. If you go to that repo, you'll see some demos that allow you to build a complete OpenStack cluster in EC2 with the Romana Cloud Native SDN underneath. So it allows you to build isolated tenants without an overlay inside of EC2. So that demo is available right now if you go there now. Cool. You can reach me at chris@romana.io. I tweet at Chris_Marino, at Chris_Marino. And for anybody that's in the Bay Area that happens to be listening to this podcast before February 11th, which is in about a week or two, we are slated to be presenting at the Bay Area Kubernetes meetup on the 11th.
Oh, excellent. That one's growing very, very fast. JJ.
It really is. It really is. Yeah.
Very cool. Well, listen.
We have a Slack channel, romana.slack.com. Again, all that stuff is available on the project site. So that's probably your first stop.
Yeah, we'll get all that in the show notes as well for people. Well, listen, this is very, very cool. Like we said, we always like to sort of highlight stuff right when it's kind of coming out of stealth. I would love to have you guys come back on, at some point 3 months, 6 months from now, because I'm very curious how, the interaction between, kind of network teams and operations teams is going to be with, these new tools that kind of have these native developer interfaces to them, and how the teams kind of interact, how they figure out how to, get visibility of what's going on. So I'd love to have you back on in a few months and kind of give us some feedback as to how all this stuff's working out.
I'd love to come back, Brian. And, touching on that point, those are the people that I spoke to every day at Cisco. Yep. CCIEs, guys that are scratching their head trying to figure out, how the heck am I going to build an overlay? What the heck does that mean? Right. So yeah, that I would love to talk about that. That's probably an entire show's worth of interesting issues.
Yeah, absolutely. Well, very cool. Well, listen, I'm going to wrap it up with that. As I said to everybody, all the notes and, where to find Chris and where to find all the information on Pani and the Romana Project will be in the show notes. So don't feel like some of this stuff might have needed to be visualized. With that, I'm going to wrap it up. As always, thanks to everybody who's been making contributions to the Krispy Kreme Challenge that's coming up in a couple of weeks. And we will talk to everybody next week. Thanks.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.